Some they say in the race it sounds like a mosquito because it's coming from far and it's increasing like a mosquito in your ear.
Welcome to Third Angle. In this episode, we're thrust into the electric future of motorsport. I'm your host, Paul Hames from industrial software company PTC. In this podcast, we share the moments where digital transforms physical and meet the brilliant minds behind some of the most innovative products around the world, each powered by PTC technology. Motorsport is being redefined. The future of racing is happening now with the growing popularity of Formula E, the FIA eTouring World Cup, and the arrival of off-track Extreme E. Electric racing has hit the mainstream and is capturing the world's attention. As true pioneers, responsible for the first ever electric touring racing car, it's no surprise Cupra Racing are reigning champions in many of these events. Not only is the Cupra e-Racer setting the standard for high performance, the company is also reshaping the perception of electric racing. And if you think it can't compete with combustion, think again. As you'll hear in this episode, the passion, the speed, and the drive to achieve more, it's all there. And to see these cars up close and find out about the company's vision, our producer, Alan Ruiz Terol, visited the head of Cupra Racing, Xavi Serra, at their factory in Barcelona.
So here we said this is where our dreams become reality, our Cupra dreams. And here in this first part of the building, we have some finalized cars ready to deliver to our customers. And we have our activity divided into in here, in this big place, is where we transform our Cupra road cars coming directly from the factory. And we fit them with different rims, different pedals, spoilers, something. Well, Cupra is a brand born in the 21st century. We call ourselves an unconventional challengers because we want to do things differently. In 2018, we had a commitment and a vision to electrify our motorsport portfolio. We started our way earlier than the society or the motorsport world did. We felt a bit, especially at the very beginning, where we had our first ever touring electric car, and there was nowhere to race it, and there was only touring car combustion races around the world. So we were pioneering the thing too early. Here we see the final racing car, ready to be delivered to our customer. This is a process that we do from zero to the delivery. And now what we see here, so we have a car that looks like a Cupra Leon, but with a really big wing, stretched fenders. We have a roll cage inside. You see, open the door now. We have a racing bucket. You see here, we don't have any seat for passengers, any belt, any fancy thing. It's pure performance. We're looking for pure performance and not comfort at all. So we first will have a look to the e-Racer. Here we have both cars, the cars that have been racing in the FIA World Touring Car Cup. So the competition was finished kind of 1.5 months ago. And these are the two cars that competed there. Actually, this is the champion car. And we are just going through an assessment of how the car ended up the season. It's a complex car that we started to design 3 years ago. And this is as well coming based on a road car body shell from the Cupra Leon, in where we fit an electric racing battery and electric motors that features almost 700 horsepower, all in the rear axle. It's a rear-wheel driven car with no gears. It's a single gear. And we have an acceleration of from 0 to 100 kph in only 3.2 seconds. And the motors are producing almost 1,000 Newton meter torque.
Is there like, how big of a difference is there still between electric racing cars and non-electric racing cars?
Yeah, actually the electric technology is more efficient than the combustion technology. An electric motor has an efficiency easily above 90%, whereas a combustion engine is only around 40%. But still, we are learning this technology. We do believe racing will be electric, and is electric already, but will be more electric in the future. And the proof is these cars this Cupra Racer that produces an amazing performance, and it's a lot of fun for the drivers when you see all of them switching from the combustion to the electric. And you always expect, let's see how these guys will react, and they say, well, all of them said the same thing. Wow.
Do you want to get inside the car?
Yeah, let's jump in.
Inside the champion.
Yeah, inside the champion car. So here I'm sitting in a higher position because I have the whole battery, the 65 kilowatt hour battery under my seat and behind my back. So we have to place this big battery all around. And here I do have my cockpit with very few buttons. Again, a lot on the steering wheel and a lot of information on this little dashboard, in where I can see the state of the shock, state of the battery, temperatures, electric isolation, everything.
It's just like numbers in different colors.
Numbers and different colors, yeah. But they all are important, and they all mean a lot, and we need to monitor all this at all time. So the headlights and the rear lights are blinking, which means that the high voltage is on, and this green light inside means that the car is safe to be driven, so the isolation is fine. So I push the ignition button.
Sounds more like a spaceship or
a rocket. And some they say in the race it sounds like a mosquito because it's coming from far and it's increasing like a mosquito in your ear.
Basically the sound is the wheel.
Is the wheel, is the gear that the wheel has, the motors. It's basic. You don't hear anything else than this. And for the drivers, once you are in the car, you hear much more the tires, the dust, the gravel. So it's completely different, but the performance is same or even more than a combustion engine. Yeah, we don't feel the lack of really the combustion noise. It's something people tend to say electric cars are silent and then they are not emotional, but that's not actually the case at all. Future of motorsport will be electric, for sure. The perception of electric motorsport and electric fans in motorsport has changed a lot in the past 5 years, I would say. From very few, let's say, people defending it and a lot of haters, is now switching to not maybe half yet, but people start to see that performance and electrification are a perfect match. These two worlds are converging. The Cupra's vision and the motorsport world ecosystem is conveying to one single path that will be electric. I'm proud of what we have achieved so far. We are the only brand to have won electric high-level competitions on track, winning twice the FIA TCR World Cup, and winning as well. We are race winners in Extreme E off track, so we are starting to be successful there.
The the checker is out. It is Vinci for Agent Tombe.
And on the other hand, we keep on supporting our customers around the world, winning nationals and regional championships with our Cupra Leon competition.
That was Xavi speaking to our producer, Alan. Now, most people at PTC and in my personal life know that I have a very keen interest in motorsport. And I do know that to be competitive on the track requires countless hours of effort and dedication. But a lot of the work happens in the early stages of the design of the individual vehicle components. And that's why Cupra uses PTC's 3D computer-aided design software, Creo. Let's find out more, and time to meet our expert, Brian Thompson, who heads up PTC's CAD division. Brian, how do you think Creo has assisted Cupra in remaining competitive?
Yeah, great question. And let me just start by reminding the audience what Creo is. Creo is a 3D design package. It's PTC's flagship 3D design tool that is really present in this part of the industry. We actually have a strong presence in motorsport and in automotive in general. And Cupra's actually been a customer of ours for a long, long time. And it's only natural that a company that has to wring every last ounce out of the performance of their vehicles for the type of market that they are in, that they would use, high fidelity 3D CAD software that allows them to digitally represent every single part of their design right down to the last, thousandth of an inch. They're right there in 3D, so they can make sure there are no mistakes. The full design is there. They can do all the validation work and all the development, and actually have a number of design engineers collaborating across the entire vehicle design, whether it's the design engineers working on the seat for the driver or the suspension or the various versions of powertrain that this team might be working on, whether it's electric or traditional ICE powertrain. You have to have all those different folks collaborating together on a single 3D design that they can then be sure can be handed off to manufacturing efficiently. And, that's what 3D design does. When you're doing everything digitally, you can collaborate quickly, make mistakes quickly, correct those and move on, because, mistakes made in the digital world, they don't cost you much. You just keep working and collaborating with the team. So it's great to have Cupra working. And I feel like they've known this for many years, and that's why they've been a customer of ours for many years. It's exciting to see what they've been up to recently.
That's great. And I think, time to market for any manufacturer is critical, but for the race team, you've got a deadline, which is the race that's happening, the next weekend or the weekend after. And so that deadline simply doesn't move. And a lot of what we do here is about helping them streamline their processes. And can you perhaps share a few examples about how we've streamlined what it is that Cupra do to get the car to the track on time?
For a company like Cupra, or for a division of a larger company like Cupra, a racing team, especially given the domain that they work in, where it's all about performance and it's all about getting the power to the ground and doing it with the lightest possible vehicle they can, that's still safe, that still meets all the rigidity requirements and safety requirements. What we find is there is a significant application of technology that we call simulation technology that's used to validate that the design will meet the requirements, the stress requirements, the pounding that these vehicles have to take. You could spend weeks testing one out on a track, or you could spend a few days doing a series of simulations in the digital world to confirm that the design will meet its requirements. Or even more importantly, to realize, oh, wait a minute, my design's not going to meet the requirements. Let me make some changes while the product's still in its digital form, so that I can ensure that it will, in fact, meet its design requirements. These kind of things can be huge double-digit % efficiency improvements for these teams. Not only are they able to minimize the amount of rework they have to do when they finally do get out and test a prototype by doing simulation across all of the critical components in the design, but they save so much time, because every time you have a broken part as part of a test, now you're talking, maybe for them it's days, because they can rapid prototype directly out of Creo, and it might be weeks if it's a difficult to find material or so forth that they have to produce, or maybe they're additively manufacturing some parts directly from inside Creo. Even that can take an overnight day. Additive manufacturing and complex parts can take a long time. So we really see with teams like Cupra a lot of application of simulation technology from PTC. And, the way we've integrated it with Creo, it's right there at the fingertips of the design engineer. They don't have to go through some special process to utilize that technology. They just build their loads and boundary conditions right there inside the design and define the test exactly the way they would in the real world, but they're doing it digitally and they're doing it right there on their production design. So it's really a time saver for them. You're talking 10, 20, 30% time savings in getting the design of the vehicle done by virtue of the fact that we've integrated these simulation technologies so deeply into the design process for customers like Cupra to use.
And I guess also that goes beyond what we would say maybe is the traditional sort of simulation work around sort of structural analysis. But in the electric vehicle world, where we've got batteries with high energy densities and keeping them cool is essential, it's all about also simulating airflow and the actual way in which you can manage those thermal properties as well as the structural ones.
Yeah, it's interesting in that world where airflow around the outside of the car is not just about having enough, say, downforce for the vehicle anymore. It's also about, are we getting enough air to the underside of the car where we have some fins that are there strictly for providing cooling to the battery pack? I'm just using that as an example. I'm not sure if Cupra cools the battery in that way. They might use an active system, but the point is that for systems like that, there's actually a lot more thermal management, to your point, that you need. And certainly that type of simulation is also possible right there inside Creo as part of the design process, like other more obvious types of simulations that you might have that would be a normal part of motorsport for decades, right? This is a new genre of simulations that design engineers have to do. But hey, thermal analysis, fluid flow analysis, all there and possible as part of the Creo suite of products. And so it's great to see Cupra taking advantage of them.
Thanks to Brian for his insight and to Xavi for showing us around Cupra Racing's factory. Please rate, review, and subscribe to our bi-weekly Third Angle episodes wherever you listen to your podcasts, and follow PTC on LinkedIn and Twitter for future episodes. This is an 1860 production for PTC. Executive producer is Jackie Cook, sound design and editing by Ollie Guiu, and location recording by Alan Ruiz Terrell, and music by Rowan Bishop.